mind-bending objects in the entire universe, the black hole. So, what is a black hole really? When you boil it all down, it's basically a spot in space where gravity has gone completely off the charts. It's so powerful that it creates like a cosmic one-way street. Once you cross that line, there's just no coming back. And to really get our heads around that, we need to go back to the beginning. Where did this wild idea of a point of no return even come from? This isn't some sci fi movie concept. It actually comes straight from the brain of Albert Einstein himself. His theory of general relativity, it's a big one, basically said, hey, what if you could squish a ton of mass into a super, super tiny space? Well, the theory predicted you'd literally bend the fabric of space-time, creating a gravity well so deep that, yeah, nothing could ever climb out. Okay, so how in the world does the universe actually do that? How does it pack so much stuff into one tiny spot? Well, it happens during one of the most spectacular, most violent events you can possibly imagine, the death of a giant star. So let's walk through it. Imagine a star, way bigger than our sun, just shining away for millions of years. But eventually, it starts to run out of fuel, and when that happens, it can't fight against its own massive gravity anymore. The whole thing collapses on itself, just bam! It triggers this unbelievable explosion we call a supernova. And what's left behind? The crushed, squished core, now an incredibly dense point. A brand new black hole is born. All right, so now that we know how they're born, let's get a little closer. Let's, take a look under the hood. What are the actual parts of a black hole? What would you even see? First up, you've got the most famous part, the event horizon. Now, this is crucial. It's not a solid surface you could, stand on. Think of it as an invisible border. It's the literal line in the sand. The second you or anything else crosses it, that's it. Game over. There's absolutely no way back. Okay, but wait. If black holes are, well, black, invisible, how do we even find them? We look for the mess they make. It's kind of like trying to find an invisible person walking through a puddle. You look for the ripples. That's the accretion disk. It's this bright, swirling, super hot whirlpool of gas and dust that's getting sucked in. It glows like crazy, shoots out X-rays, and basically acts like a giant neon sign pointing right at the black hole. And then, at the very center of all that chaos is the singularity. I mean, this is where things just get bonkers. This is the point where all that star stuff, all that mass, is crushed into a space that has zero volume, but infinite density. Think about that for a second. All of our laws of physics, everything we know about space and time, it just breaks. It completely falls apart. It's the ultimate mystery. Yeah, that's right. The singularity is where our rules break. And as you get closer to a black hole, the fundamental rules of our universe, well, they start to get really, really weird. So let's get down to it. Why can't anything escape? It's all about something called escape velocity. Okay, so here on Earth, if you want to launch a rocket into space, it has to go about 11 kilometers per second to break free of our gravity. But a black hole's gravity, it's so intense that its escape velocity is faster than the speed of light. And since we know nothing, absolutely nothing, can travel faster than light, well, that's why nothing gets out. It's a cosmic trap with no exit. And the weirdness doesn't stop there. This intense gravity also messes with time itself. It's a thing called time dilation. Near a black hole, time literally slows down. So imagine this. You go hang out near the event horizon for a bit, while your friend waits for you far away. For you, maybe only a few minutes pass. But when you get back, your friend could be years, even decades older. It's absolutely mind-bending. For the longest time, everyone just assumed black holes were these eternal prisons. Once something goes in, it's gone forever. But then, the brilliant Stephen Hawking came along and completely flipped the script. He figured out that because of some wild quantum physics, black holes aren't totally black. They actually leak a tiny, tiny bit of energy. We call it Hawking radiation. And over incredible, almost unimaginable amounts of time, this leak means they can actually evaporate and just disappear. So, back to that earlier question. How do we actually hunt for these things if they're invisible? Well, scientists have to be cosmic detectives, right? They look for clues. They see stars wobbling or orbiting what looks like nothing. That's a big clue. They use special telescopes to spot those blazing hot accretion disks giving off X-rays. They even listen for gravitational waves. These are literally ripples in space-time that get sent out when two black holes smash into each other. And incredibly, with things like the Event Horizon Telescope, we've now managed to take an actual picture of a black hole's shadow. How cool is that? And one more thing you should know, not all black holes are created equal. They come in different sizes, kind of like a cosmic small, medium, and large. You've got your stellar black holes, the ones born from dead stars. Then you have these supermassive ones, and these are the real monsters. We're talking millions or even billions of times the mass of our sun. They're hanging out at the center of pretty much every galaxy, including ours. And then there's this hypothetical idea of tiny primordial black holes, maybe created way back at the Big Bang. We haven't found those yet, but who knows? So, with all this talk of destruction and mystery, you might think black holes are just the villains of the universe, right? Just cosmic vacuum cleaners. But what we're learning now is that's not the whole story. In fact, they might just be the architects of the entire cosmos. And honestly, this is probably the biggest takeaway of all. There aren't just destroyers. They're absolutely essential. That supermassive black hole in the center of our own galaxy, it's like the gravitational anchor holding the whole Milky Way together. The energy they blast out into space can kickstart star formation or shut it down completely. They are literally shaping how galaxies grow and change over billions of years. So yeah, without them, the universe would be a totally different place. We might not even be here. So, when you think about it, black holes really challenge everything we think we know about reality. They represent the edge of our knowledge, that point where our physics just gives up. They are the ultimate cosmic question mark. And as we keep staring into that darkness, you just have to wonder, what other incredible secrets are they hiding from us?